Okay. So 3-2, a little bit of this is going to be review for you, a little bit maybe new. We're going to put a couple things together today. So what we're going to try to be doing by the end of the period are graphing a linear equation. Giving an equation of a line, can you plot the points and be able to graph it? So, a couple things that we need to do to be able to build up to that first. First of all, we need to be able to make sure that a point is on a line. Now remember, a line is made up of an infinite number of points. So there are an infinite number of answers that make up a line, that make up a point, or make up a line. Yeah, so both of these could potentially be yes, both could be no, one could be yes, one could be no, it just depends what numbers you're given. What we're trying to figure out is it a solution? Now, we've done this before where you just had a single variable in the equation, you plugged a number in for that variable, and if you got a true statement, it was a yes, and if you got a false statement, it was a no. We're doing the exact same thing here. The only difference is there's two different variables you have to worry about now. When we have a coordinate, it's an x and a y. So you're plugging two different numbers in, and you need to make sure that you plug them in the correct place. Now, this first one won't really matter because it's the same number. I'm plugging x and y in, 3 and 3 for both. Putting it in the equation, 5 times 3 plus 3 equals 18. And then I'm simplifying what I can to see, are these the same, yes or no. So 5 times 3 on the left is 15. Plus 3, does 15 plus 3 give me 18? Yes. So that tells me that 3, 3 is a point on the line. So long story short, it would be a yes. It works. Okay. Plug in 5, 7. Same original equation. Again, 5 is the x, 7 is the y. So that would be 5 times 5 plus 7 equals 18. 5 times 5 gives me 25 plus 7. Does 25 plus 7 give me 18? It does not. So long story short, that one is a no. 0.57 is not on that line. It is not considered a solution. Make sense? Okay. You guys try the next one with your partner. Plug them in. Let's call this guy point A. Let's call this guy point B. Determine, are they points on these lines? What do you think for the first one? Yes or no? Second one? Yes, those are correct. All right, so let's see why. If I plug the first one, point A, we're checking here. 7 times 2 minus -4. We're checking that it equals 10. 7 times 2 gives me 14. Then you have minus a negative, which is the same as what? Plus. Does 14 plus 4 give me 10? And then next one is going to look very similar. 7 times 2 minus, now it's a positive 4 in there. So then you have 14 minus 4, which equals 10. Okay? Any questions? Checking if you have a point on a line. Good. Okay, next thing we need to review is how to get a y, well, a variable alone. I mentioned in the last chapter, you guys had problems like this on the last test, that this was going to come back. We're going to be doing this a lot this chapter. And we are always isolating the y. We're going to be isolating the y in these problems because eventually we want to be able to plug numbers in for x and get y's out. If the y is alone, it is very easy to figure out what y is equal to. So, getting the y alone. Remember, you are not solving. We're not going to get an exact answer here. We are instead just moving things around to give us a different version of this same equation. What would I need to move in this first equation to get the y by itself? 6x. How do I move the 6x to the other side? Add. Now, this is a mistake I was noticing on the test when I was grading it. I have a lot of people trying to add together things like that, 11 plus 6x. Are those like terms? They are not. All you can do is put them next to each other. 11 plus 6x, and that's it. The y is by itself. That's my answer. Okay. Let's do one more together. 2y minus x equals 9. What would be your first step to isolate the y? Add x. So we always want to move our x term to the other side. That leaves me with 2y, 9 plus x. Again, they are not like terms. Just 9 plus x. Next step to get the y by itself, what do? Divide by 2. And we are, remember, dividing every term by 2. Remember, we're really dividing that whole right side all over 2, but it's easier to divide it into each piece. It's going to make it a better version of the equation for us later. 9 over 2, you can leave it as a fraction, or it is an exact decimal. You could say 4.5. What number is in front of that x? 1. So you could say x over 2 if you want, or you could say 1/2 x, or you could even do the decimal. 0.5x would be fine as well. And then again, our y is alone, and that's the goal here, so that would be your answer. Okay, can you guys try a couple? Just practice. All right. Try these two. I'll give you a couple minutes. Isolate the y. Make sure you give me exact answers. Do I have any volunteers that want to put the first one up on the board? Do you want to do the first one? Do you want to do the second one? If you want to put your work up too, that would be amazing.
Yeah.
That'll be YouTube later.
What?
You're being recorded for YouTube right now, the audio. So say hi to all your viewers. No pressure.
We'll say hi. Hi.
So first one here, I would add 9x, which Sasha flipped them, but it means the same thing. 15 plus 9x equals 3y is what you should have on that line. And then when you divide each term by 3, you should have a 5 plus 3x equals y. On the one on the right here, subtract x on both sides. Remember, that's a positive x there. That's why we're subtracting. So then I have a negative 6y, 18 minus x, divide everything by negative 6. Now, the only thing I would edit here is I wouldn't leave this as negative over negative, because that's going to be messy if you need to use this later. Negative over negative simplifies to positive. So I would write either negative 3 plus x over 6, or you could say 1/6 x would be okay as well, like we did in that last problem. Okay? Any questions getting the y alone? Good. Okay, next thing we're going to do is graph, and I have graph paper for you guys. There are more graphs than you need on this paper. Keep it. We're going to be graphing a lot in this chapter, and if you need extra, I've got a whole pile of it on the front table. So as you run out of space on here as we're doing notes and things, or you're using on your homework, just grab more from the front table if you want it.
All in the very
All right, so you guys can just number these however you want. You can work on the sides here. So you can do it all on the notebook or the graph paper. You don't need your notebooks right now. Okay, so the goal of this lesson, like I mentioned before, is we're trying to be able to graph a line. This is the most basic way to graph a line. We're going to, in 3 steps, get the y alone. Step 2, we're going to make an xy table and plug in points. And then step 3, we're going to take the points we have and we're going to connect them to make the graph. To draw a line, you need a minimum of 2 points, but you can always do more than that. That's just the minimum. So if you have 3 or 4 or 5 points in your table, you maybe are more confident in what your line's supposed to look like. All right, so we're going to do the first one together. My equation is 4x minus y equals 1. First step is to isolate the y, get the y by itself. So that's what we were just practicing. How do I get the y alone? What would be your first step? What do I do?
Minus 4x.
Subtract 4x on both sides. So then I have negative y equals, can I do 1 minus 4x? They like terms. No. So just 1 minus 4x. And then my second step to get the y alone is I've got to get rid of that negative. So what do I divide by?
A positive or a negative?
Divide everything by negative 1. What happens when you divide by a negative?
It turns another negative positive.
It's going to switch all your signs. The negatives are going to become positive and the positives are going to become negative. So I will now have a positive y, a negative 1, and a positive 4x. Once the y is alone, we're going to make an xy table. And we're going to find points that work in this equation. Now we're going to start with x's. Those are our inputs. We're going to get out y's. Those are our outputs. This is why we want the y alone, because that's the output. We're trying to figure out what it equals. The good news is you can pick any x value you want here. You need to pick 2 of them. If it's me, I'm picking 0 every single time because that's a really easy number to plug in. And then I would pick another number, 1, 2, 3, 4, maybe even stick with the positives so you don't make mistakes with negatives, right? So give me another number you want to use for x.
1.
1, sure. Okay. Now we're going to plug these numbers in for x. We've done this before and fill out the table. You guys did it in your guided notes yesterday. If I plug 0 in, 4 times 0 gives me 0, plus negative 1 gives me negative 1. There's my first point, 0, negative 1. Plug in 1. 4 times 1 gives me 4, plus negative 1 gives me 3. Yes? Yes, you can use your calculator for this, definitely. So, well, you can use your calculator to plug them in. Now, I will tell you, like tests and quizzes, there are going to be parts where you are allowed to use a graphing calculator and parts where you are not allowed to use a graphing calculator. So make sure if you're using the calculator for like filling out a table and stuff, you're not using like the graphing functions because you won't have that on the actual test or quiz. Does that answer your question? Okay. And we'll practice more with the actual graphing calculator a little later in the chapter. Right now, we're just trying to do it by hand first. Okay, so 0, negative 1, plotting it, left, right, 0, down 1. Second point is 1, 3, so that means to the right 1, and up 3. And again, that's the minimum. 2 points make a line. We're going to extend it all the way through our graph, and we're going to put arrows on both sides to show that it goes on forever. Again, that was the minimum. So if you plugged in 3 or 4 or 5 points in your XY table, you'll see a really nice line show up. It's going to be maybe more likely that you have it correct because you're going to see that linear shape. It's really easy to make a mistake if you only have 2 points because it could look like anything, right? But if you have 3 or 4 or 5, it's likely that you're going to see if you've made a mistake because they won't line up. Okay? Good? Questions? All right, let's do one more together. Same idea. I get the y alone, make an xy table, plot my points to get my line. My equation is negative 2x plus 4y equals negative 8. How do I get the y by itself? What's your first step be? Add 2x. Are negative 8 and 2x like terms?
No.
No. Negative 8 plus 2x. Second step is do what? Divide by 4, divide by 4, divide by 4. Y equals, what's negative 8 over 4?
Negative 2.
Negative 2 plus 2 over 4 is 1/2 if you reduce it, or if you wanted to say 0.5 there you could. All right, xy table. I'm going to choose 0. Give me another number. 2. I like 2 because 1/2 times 2 is going to give me what? It's going to be a whole number. If I plugged 1/2 and 1 in, 1/2 times 1 would give me a half. You're going to have decimals then, which maybe are a little harder to graph. So just kind of look at your equation and judge it. Again, 2, if I plug it in, 1/2 times 2 is 1, plus negative 2 is negative 1. If I plug in 0, 1/2 times 0 is 0, plus negative 2 is negative 2. So then I can graph those. 0, negative 2, 2, negative 1. Again, extend it all the way through your graph, arrows on both sides. And if you want to check it, plug a couple more points into that xy table and see if everything lines up nicely. Okay? Make sense? Think you can try one? Okay. Try this one. Same thing. Get the y alone. Plug 2 points in the xy table. Actually, let's decide together so we always use the same x's. What x's do you want to use?
0. 0 and 4.
There we go. All right. Okay. I'll work this up the next worksheet. Down, divided. So you want to get that y piece alone before you divide. That should be your very last step. Have it here. Have a good night. A couple more minutes. Don't check it. All right, first step, I would subtract the 6 over. So 3x minus 2y equals, and are those like terms? Yes, get 6. Then subtract 3x. So then you have negative 2y equals 6 minus 3x, and then divide everything by negative 2. So then that will give me y equals 6 over negative 2 is negative 3, and then that's another place where you're going to have a negative over negative, so it should be positive here. You can either have 3/2 x, or you could say 1.5x would be okay also. If you plug in 0, you should have gotten out negative 3. If you plug in 4, you should get out 3. Right? 12, yeah, that's good. Okay. 0, negative 3 should be here. 4, 3 should be here. There is your line. And if you're not sure, just put in more points into your XY table. Make sure you have arrows on the end of that line. I will take off points if I don't see that. Otherwise, it's not a line, it's a line segment. Something different. Okay, any questions graphing a line from an XY table? Okay, last thing that is in this lesson are the 2 special cases. All of the lines that we have done so far are what we call oblique lines or diagonal lines. The 2 special cases are horizontal and vertical lines. So what I need you to put in your notes is this little chart. We're going to put the difference between a horizontal and a vertical line. And then we're going to graph these as the last step. Don't put away that graph paper just yet. We're going to do a couple more little graphs on it in a second. But somewhere in your notes, make this little chart, horizontal and vertical, 2 special cases. Again, the third type is oblique. Those are just all of our diagonal lines that we just practiced. Okay, so I'm going to start with a sketch of both of them. Here's my little XY plane. Well, the horizontal line is going to look something like this. A vertical line is going to look something like this. So left and right with no slant, or up and down with no slant. Those are our horizontal and vertical line. Their equations are obvious because unlike all of our oblique lines that have an x and a y, these will only have either an x or a y, but not both. Horizontal lines, their equation will look like just y equals some number. Vertical lines, their equation will look like x equals some number. Okay. Does a horizontal line cross the x-axis? No. Does it cross the y-axis? Yes. It crosses the y-axis at whatever that number is. If it's y equals 3, it crosses the y-axis at 3. If it's y equals negative 7, it crosses the y-axis at negative 7. So that's how I remember which one's which, because it crosses that axis at that number. Okay. Vertical, does the vertical cross the x-axis? Yes, at that number. Does it cross the y-axis? No. Now the only exception to that is you could have a vertical line on the axis or a horizontal line on the axis, in which case it would always be touching it. Okay? So back to our graph paper. Whenever you're done with this, we're just going to practice graphing a couple horizontal and vertical lines. These are the easiest ones to graph as long as you remember which one's which. We'll do the first couple together, and I'll show you two different ways that you can graph these. We'll do line A and B together. Okay, first thing you can do to graph is you can, just like our XY table, plot 2 points that are on that line. If we see x equals -3, you could set up a little mini XY table. And x equals -3 means every point on that line will have an x coordinate of -3. And all we need are 2 points to make a line, right? So -3, 8. -3, 0. -3, 24. Who cares, right? As long as it's an x is -3, it's on that line. So there's nothing we're actually plugging in here. We're just creating points that fit that description. X's that are -3. Now, if you plot whatever 2 points you've chosen, -3, 0 would be there. -3, 8 would be like way up here somewhere. It creates your vertical line. So you don't even have to remember that it's vertical. As long as you can find 2 points that have that same x coordinate, it will create the vertical line. Now the other way to remember it is you know it crosses the x-axis at -3. So this is how I do it. I just make a point on the x-axis at -3, and then I know it's vertical, so I draw my line from there. Okay? So if I were going to graph y equals 7, option A is I could just, on my y-axis, make a point at 7, and then I know it's going to be horizontal. So I can draw my line from there. The other option, if you don't remember what it is, make an XY table, and it doesn't matter what you put in for x. So let's say I put in 0 and 1. Your y coordinate must be 7. That's why it has that equation. Every point on that line has a y coordinate of 7. That's why it looks horizontal. So then you could plot those. You could plot 0, 7. You could plot 1, 7, which would be here. And then connecting them would create the line. Okay? So you can either find 2 points and create your line, or plot a point on the axis and then remember which kind of line it is. You guys, you can do it on the same graph on your paper. Try C, D, and E. Graph them real quick. We'll put them on the board, and that'll wrap up our lesson. Line C, y equals 0. You should actually just have a horizontal line on your x-axis. It's a horizontal line that touches at 0, which is our origin. Y equals -2 will also be a horizontal line at -2. Would look like that. Or again, you could plot 2 points that have a y coordinate of -2. X equals 4 should look like this on your paper. Okay? Any questions? Graphing horizontal, vertical, oblique. Okay, great. So, I'm going to give you 2 homework assignments right now. One is for tonight and one is for tomorrow. They are the next 2 worksheets in your packet. The first one that is due tomorrow, I'll flip back to that in a second if you need it, is the next worksheet has something about toggle on the top of it. That worksheet, the tables are already set up for you. Most of the problems, you're set to just plug in the numbers, plot the points. I think there are a couple at the very end where you might have to get the y log first, so make sure you show that work. That's the one we're going to check in tomorrow. The following worksheet in the packet says something about like copy something. That one you have to make your own XY tables like we were practicing. Okay, that says at the top, use X, Y tables, graphs, so you can be sure on Thursday when I check that worksheet in, that I will be looking for those tables next to each of the graphs. Okay? So, why am I giving you 2 homeworks? Because tomorrow you are working on Desmos. So you have a project or an activity that we're doing in there. How many of you have used Desmos before? 1, 2, 3. Okay. So Desmos is an online graphing tool. We're going to do like a little introductory activity into that tomorrow. So you need to have your Chromebooks ready to go. That's going to be the majority of our, I guess, call it lesson tomorrow. You guys are going to be working in pairs, working through how to use the program. It's super cool. You guys are really going to like it because it's online, it's free, it's always available. It's something that you can use on your air test actually as well. So we're going to try to be using it a lot more now that we're actually getting into graphing stuff. It's going to be pretty useful. Okay. So tomorrow we'll check in the toggle worksheet and then we'll work on Desmos. Tomorrow night's homework is the following worksheet. If you want to get it all done, you can get it done tonight. Have no homework tomorrow. Okay? Good? All right. I'll do the cell phone lotto and you guys are on your own for the last few minutes. You can get started on your homework.